Hello everyone, my name is SN Patil. In this video lecture, we will discuss numerical solution of first order ordinary differential equation by modified Euler's method. So first we consider initial value problem. dy by dx is equal to function of x and y with initial condition. Okay, now here the equation 1, it can be written as dy is equal to dx is multiplied to the function and then integration. Okay, the integration of dy is y, put upper limit, lower limit here, and keep this term as it is right hand side. Okay, now put this y suffix x naught in a right hand side. Okay, now here apply trapezoidal rule. Then we get y suffix 1. Y suffix 1 means what? That is the y suffix 1 means value of y at a x1 is equal to y naught plus h upon 2 in bracket f at x naught y naught plus f at x1 y1. Okay, the first modification of the y suffix 1 is it can be written as y1 raised to 1 is equal to y naught plus h by 2 f at a x naught y naught plus f at a x1 comma y1 raised to 0. This is the first modification of Euler's method. Okay, now the second modification, see the power is changed here. Y suffix 1 raised to 2 is equal to y naught plus h upon 2 f at x naught comma y naught plus f at a x1 comma y1, and here power is 1. In general we can write y suffix 1 raised to n is equal to y naught plus h by 2 in bracket f at x naught y naught, this term is constant as it is, plus f in bracket x1 comma y1 raised to n minus 1. Okay, now this is the nth modification term of yn. Okay, so this is the for what? For y suffix 1. Similarly, the successive modification of y2 are given by y2 raised to n is equal to y1 plus h by 2 in square bracket f at x1 comma y1 plus f in bracket x2 comma y2 raised to n minus 1. Now here the general formula we can also written as now I am writing the same formula, that is nth plus 1 modification, that is y suffix 1 raised to n plus 1 is equal to y naught plus h by 2 in bracket f of x naught comma y naught plus f in bracket x1 comma y1 raised to n. Okay, square bracket is complete. Okay, the nth modification we can write in this way also, y1 suffix n plus 1. Now the question is, when we stop this process, when the difference between y1 raised to n plus 1 minus y1 raised to n is very small, is less than epsilon. That is, error tolerance is very, very small. Okay, then we stop the iteration. Okay, now let us discuss the example on the modified Euler's method. Solve initial value problem dy by dx is equal to 1 minus y comma y at 0 is 0 by using Euler's modified method to find y in bracket 0.1 correct up to 4 decimal places. Okay, now here see the requirement of the formula, you can consider this one or this one. Okay, the requirement is y naught x naught y naught x1. Okay. Now this x1, sorry, x1, that is the iteration number. Now this y1, okay, this y1 we can find using the Euler's method. Okay. So as per as the requirement is concerned of the formula, we calculate the function at x naught, y naught. We identify y naught, h, okay, and then we proceed. Now let dy by dx is equal to, let dy by dx is equal to 1 minus y. Okay, that is the function. Function is f of x comma y is equal to 1 minus y. And with condition, what is the condition? Y of 0 is equal to 0. It means what? This is given y at x naught is equal to y naught. That is the value of the x naught is 0 and value of the y naught is 0. Okay. Now we got the x naught, y naught. Also the h. H here we consider 0.1. Okay. H is 0.1. Okay. Now we also calculate the value of the f of xy at a x naught, y naught. That is 1 minus y naught. The value of the y naught is 0. That is 1 minus 0. So we get f at x naught comma y naught is equal to 1. Okay. Now, also we find the x1, y1. So this is the value of x naught. How we get the x1? X1 is obtained by x naught plus h. Okay, that is x naught is 0 and h is 0.1. So x1 is equal to 0.1. Now the y1. Here we calculate the y1 by Euler's method. Okay. Now by Euler's method, y1 is equal to y naught plus h f of x naught comma y naught is equal to the value of the y naught is 0 plus value of h is 0.0, sorry, 0. H is 0.1. H is 0.1 and the function we calculated, that is 1. Now 1 into 0.1. So we get the value of the y1 is same 0.1 and this value we denote as a first modification, initial modification. Y1 raised to 0 is equal to 0.1. Okay. Now all the value we have calculated here. Now I am writing the formula by Euler's modified method. Y suffix 1 raised to, you can write n, yeah, n plus 1. Now I am writing the n plus 1. Y naught plus h by 2 in bracket f of x naught comma y naught plus see here the formula we have write this plus f of x1 comma y1 raised to n say equation number, suppose this is the equation number 1, this is 2, now this is 3. Okay, and here n is running from 0 1, 2, 3, and so on. Okay. Now put n equal to 0 here. N is equal to 0. N is equal to 0, 1, 2. Okay. Y suffix 1 raised to 1 is equal to y naught plus 0 point. The value of h is 0.1 divided by 2. Value of f of x naught, y naught. We have already calculated. So that write the direct one. And the function f of x1, comma, the value of n is 0, y1 raised to 0. Okay. Is equal to the value of the y naught is 0 plus, keep 0.1 as it is, divided by 2. 1 plus, what is the function? Is 1 minus y. Okay, but what is the value of y here? Y suffix 1 raised to 0. Okay, now substitute here. That is 0 plus 0.1 divided by 2. 1 plus 1 minus value of y1 raised to 0 is 0.1. Okay, so we get y1 raised to 1 is equal to 0.095. Okay, so this is the first modification. Now next, put n is equal to 1. Put n is equal to 1, that is y suffix 1 raised to 2 is equal to y naught plus h upon 2 f of x naught, y naught plus f of x1, y1 raised to 1. Okay. The value of the y naught is 0 plus 0.1 divided by 2. The value of the function at x naught, y naught is 1 plus, now its value is 1 minus y1 raised to 1. Okay. So we get y1 raised to 2 is equal to, see here, I am simplifying here, 0.1 divided by 2. This is 1 plus 1 minus the value of y1 raised to 1 is 0.095. Okay. Now calculate this value. So we get 0.09525. Okay. Now next iteration, put n is equal to 2 in equation 3. In equation 3, that is y suffix 1 raised to 3 is equal to y naught plus h upon 2 in bracket f of x naught, y naught plus f of x1 comma y1 raised to 2. Okay. Now put all the values. The y naught is 0 plus 0.1 divided by 2. The value of this function at x naught, y naught is 1. And its value is 1 minus y1 raised to 2. See, value of the function is what? 1 minus y. So we write 1 minus y, and y is y1 raised to 2. Okay, is equal to 0.1 divided by 2. 1 plus 1 minus 0.09525. Okay, so we get y1 raised to 3 is equal to 0.90, sorry, 0.09525. Okay. Now next iteration, put n is equal to 3 in equation 3. That is y suffix 1 raised to 4 is equal to y naught plus h upon 2 function at x naught y naught plus f of x1 comma y1 raised to 3. We put n equal to 3. Now put the value y naught is 0, h is 0.1 divided by 2. The value of the function at x naught y naught is 1 calculated. See from equation 2 plus value the function is 1 minus y. 1 minus y, but y here suffix 1 raised to 3 is equal to 0.1 divided by 2 and 1 plus 1, okay, minus 0.95, sorry, 0.095 okay. We put this value, so we get y suffix 1 raised to 4 is equal to 0.09523 okay. Now see the difference between the y1 raised to 4 and y1 raised to 3 is very small, okay. Now we stop the process here. So this is the y at a 0.1 is equal to 0.09523 we round okay 238 okay. Now for the second iteration, then 0.2 and again repeat the same process, okay. Now thank you, thanks for watching.